Now it's time to see how Boolean operations manifest in RISC-V assembly. So we've got soda, we've got coffee, teetotal taboo. I'm not saying it's about Mormons, but it's about Mormons. So we've also got the Boolean OR, the Boolean AND, the Boolean NOT, and the Boolean XOR. The caret here is an XOR. So compiling that, and we, of course, end up with AND, NOT, OR, and XOR, the exact Boolean operations we just put into our code. So what is AND? Well, that is the bitwise AND, and just as a reminder, here's your truth tables in the upper right corner. 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, and only when 1 and 1 will you get an 1 as a result. So AND takes three operands, the register source 1, register source 2, and register destination. It does register source 1 bitwise AND with register source 2. So it goes down the line and does the AND operation on every single bit, places the result into register destination. So the C binary operator, as we already indicated, is the ampersand, not the double ampersand because that is a logical AND, not a bitwise AND. So let's say that we are doing the instruction AND A5, A5, A4. Then let's say that the initial value of A5 before the AND operation is stabadabadoods. And at this point, I have to say that, I'm going to introduce a couple of stabadabadoods here, but these particular characters are not the ones I want. These characters are from this particular Ars Technica article, where they were talking about AI-generated characters from Facebook stickers that would make inappropriate copyrighted instances of people. Now for the stabadabadoods, I really wanted to have the Flintstones, Fred and Barney. But at the time of this class creation, of course, this capability has already been disabled in Facebook sticker creation, and I don't have a Facebook account anyways, and although there are other AI generators that could probably generate some stabadabadoods for me, I don't really want to go to the effort. Now, if any students want to make me some stabadabadoods later, in specifically this sticker format, nice, cute, cuddly format, not just like a larger thing, if you want to make that for me, I will happily re-record this section. But for now, these are going to be our stabadabadoods. And we are going to perform the AND operation between the stabadabadoods and dabadoo. And the net result of that A5 after this operation is that you go down the line bitwise 0 and 1, 0, 1 and 1, 1, and so forth. So that's what the computer is doing behind the scenes. So then the OR instruction, same idea. You've got your truth table here to remind you if you need it. OR is true whenever either of the operands is true. So the OR instruction takes two sources, source 1, source 2, performs a bitwise OR, and places the result into the destination register. And again, the single pipe is the binary OR, whereas the double pipe is the logical OR, also called the bar or double bar. So if you have your stabadabadoods and dabadoo again, and you're doing an OR operation, then the result is just go down the line 0 or 1, 1, 1 or 1, 1, 0 or 0, 0. So computer just does all the binary math behind the scenes. Then the XOR operation. XOR's truth table is true when one or the other operand is 1, but not both and not neither. So you have to have exactly one operand in order to get a 1 out of XOR, exclusive OR. So the caret is the XOR operator in C, and there is no logical XOR. So XORing A5 with A4 and placing the result into A5, stabadabadoods, dabadoo, and we get some random garbage. But again, it's just 0 XOR 1, yes, that is 1. 1 XOR 1, no, that is 0, and so forth. And the NOT, bitwise NOT, is the tilde, and so it's going to have only two operands, the source, which shall have all of its bits flipped, and the result will be placed into the destination. And truth table for NOT is just flip the bits. If it was 0, make it a 1. If it was 1, make it a 0. So that is, again, the tilde, not the bang or exclamation point, because that is a logical NOT. So if A5 had 81AA, some sort of different thing, why are we not having stabadabadoods? Because if you knot that, you get tessellated toads! Tessellated toads! Tessellated toads! Likes me some tessellated toads. And now Hypnotoad commands you to step through the assembly and check your understanding. You can create a stack diagram if you want, but it's not strictly necessary.